This has been a dream of mine to present at the dotnet Conf, and so it's finally happening. I am super excited. I have a loaded presentation, so I'm going to try to go really fast. Thank you all for joining from everywhere. I would love to hear your feedback at the end of the day. Please feel free to ask questions, and Lauren will try to stop me. Or Laurent, sorry for mispronouncing your name. And yeah, here we go. Let's do it. Initially, I'm just going to start off with explaining a little bit about mobile app development, and then we'll dive a little deeper into, more of like electronics and explaining the different items over there. So here we go. All right, where's my presentation? So our topic is Raspberry Pi hand sanitizers controlled by mobile apps. So essentially, you don't tap on it, you don't touch any of this stuff. You just have your phone, it spits out some hand sanitizer. A little bit about me. That's me. I'm basically, nothing great about me. No one really cared about me before, but that was in high school. And then in university, I met a friend. His name was Omar Atta. Love that guy. Still great friends with him. And he got me into Arduinos and tinkering with different devices. And so that's where I really got interested in mobile part of stuff. And so, changing parts of the mobile device. So for example, installing Windows 7 on a Windows 6 phone, so porting stuff in custom hardware. And, after graduating from the University of Texas, Dallas, I did a coding bootcamp at EPIC-U. Over there, I studied a bunch of stuff, including C#. And based on my final project, a company called Exigo was like, hey, what do you want to do? I was like, I'm really interested in mobile development. And they were doing Xamarin. So that's where I got introduced. I tremendously lucky. Did a bunch of hackathons, including Hack DFW, which was the biggest hackathon back then, probably still is, and also won a bunch. So that really kept me going. And then James Quick, shout out to that guy. He's awesome. He he has so many tutorial videos, and that's where I learned to do, connect the devices with the mobile apps. And, I currently live in Windsor, but I'm in and out between Detroit and Windsor. So what's my inspiration? So essentially, obviously, coronavirus is here, and it's basically started canceling everything, and you have like a lot of free time available. So give me 1 second. So I was like, okay, let's try to use that to build something instead of being lazy. And and so essentially the laziness coupled with the extra time, I was like, let's try to build like a lazy device, like instead of pressing the hand sanitizer, it just spits it and presses it for you. So I was like, great. So Xamarin is what we're going to use for mobile app development today. It's .NET. So some basics. You don't need to have any knowledge about Xamarin in order to get started with this. But there's the first thing that comes up is like, oh, what's hybrid versus cross-platform versus PWA versus native? Not too much consensus. There's not like a central body that has defined it. So essentially, cross-platform is known to be development where you're using the native API. So for a slider, as you can see over here, or a search bar, it's actually using the search bar that Android built rather than a web or a graphical one. It's like the original one. And so, and there's so many other definitions. Something like a hybrid app would be something like PhoneGap or Apache Cordova. A lot of these are dying, so most of the stuff is going towards cross-platform development, and Xamarin is among the top 3 leaders right now for for cross-platform mobile development. So it's a great time to get started. What exactly does Xamarin do? So like there used to be something called Xamarin Native, which is it's still there. It's not too popular though. Only 10% of Xamarin developers do Xamarin Native. Most of them are just going over to Xamarin Forms. I call it the instant app maker, where you just create your UI and Android automatically knows what to show. I iOS automatically knows what to show. So it's great. You know, definitely part of the future. Maui's coming, which is going to move Xamarin forward to the next level. But you know, I'm just going to be presenting Xamarin because that's what's in production. You can get started now using stuff that's supported in release. So how do you get started? It's very simple. You don't need to pay for anything. You just download. What I would use is Visual Studio for Mac. You know, just download it if you have a Mac, or you can use just Visual Studio, and you can get started. You can also kind of build with Visual Studio Code. I have a tutorial out there. You can just search Visual Studio Code Xamarin; it'll come up. But you don't really have a debugger, so you know, the best one to use is Visual Studio for Mac for sure. So let's say you have a Mac, you installed it, you just click on that button. It'll show you, you know, new project, say select multi-platform, blank forms app, just give it a name, and then just hit the play button. So far, no coding whatsoever. So all of you can do it, and that'll be your first mobile app that you have built. Okay, so it's pretty straightforward, not much to do. I will go through those steps with you as well. So I'm just going to say new instance. So I clicked on Visual Studio. It opens up after a while because obviously I'm doing so many things at the same time. Stop this. Eventually it'll open up somewhere, but that's why I started already. So once you dig into what that looks like, you'll notice this over here. So it'll say pages, layouts, and there'll be these views over here. Okay, so in order to understand how to do Xamarin Forms development, especially the UI, you know, to put stuff in, that's basically what you need to remember. Pages, layouts, views is always what I tell people. Pages, layouts, views. So if you understand that, you're almost there. You know, you'll understand what I'm going to be showing. There's different types of pages, and the layout is inside that page, and then the views are inside that layout. Okay, so that's the hierarchy that they have to follow. There's different types of pages. You know, there's the master detail page, but we're going to stick with content page. And inside the layout, there's different types of layouts. There's, you know, these stack layouts where one thing is stacked underneath the other or to the side, depending on whether or not it's a vertical or horizontal stack. Let's see, where'd that go? Okay, so what we talked about over here, I'm just going to follow those steps. I'm going to say new solution. And then, like I said, you go to multi-platform, blank app. Oh, this resolution. I don't think this will work with this resolution. Let's see. I can't build a new template using this resolution, but that's okay. We'll use an existing template. Essentially, you know, you can put in your entries, your buttons, and your stack, and then the other way also that is possible to create your UI is if you don't want to use XAML, which is like this, you know, HTML style tags, you can just use C# to create your UI. And you know, there's two ways of doing it. Both are fine, just that you don't get access to something called hot reload, where you make the changes and it appears immediately on the screen when you hit save. So I'm just gonna, you know, display something really quick. What I already have over here is, you know, a simple page. I just made a few changes. Let me go back over here. Let me change that back over here. So what I'm doing right now is I'm just essentially changing the code back to how it was initially. So I just hit play, and you know, like I showed you, I select iOS, I select debug, and then I select the simulator that I want to build it on. I hit play, and then it just starts building it and bam, you see the simulator will open, and it essentially shows you, what's there. And now what exactly is on that page? You go to the XAML file. Remember I told you about XAML? So you have the page on the top level, and then you have your layout inside, and then you have your views. Okay, so you have label, button. Now let's say you want to change this to say welcome to auto dispensers. You just want to add an S. You just add the S, hit save, and you notice how it refreshed and it showed you auto dispenser. So it's great. It's very simple, intuitive to use. Let's go to the more exciting part. Okay, connected electronics. So if you've never touched electronics before, I'm just going to give you a brief history. Let me set this up really quick. All right, we have 17 minutes, not bad. So microcontrollers versus microprocessors. Microcontrollers are extremely tiny. They usually are supposed to do only one job. You give it one task, and that's what it does. A microprocessor, on the other hand, is like a computer or a Raspberry Pi. So we're going to start with a microcontroller because it's more basic and easier to understand and follow. Okay, so direct current. So what you're dealing with over here, as soon as you use an adapter to get your USB to your micro USB, you convert the 110 volts into 5 volts of direct current. Direct current 5 volts is fairly safe to use and handle. And, essentially there's the ground and there's the live side, or the black and the red side, or the negative and the positive side. And I'll show you exactly how the flow of current goes when it's direct current. And then, so what I have over here is a microcontroller, but it's a very specific type. It's like an Arduino micro, or an ESP32 or ESP26. These are really popular ones, but this one is called a photon particle, which is almost exactly like the others, but this one also gets connected to the cloud. So you don't need to connect it to your computer in order to debug. You can just send the code to this web IDE, and it will automatically send it over once you connect it to the internet. Okay, the other thing that you should know is you see this little LED light over there. So the LEDs have two ends. There's a shorter end and a longer end. The shorter end is the negative end, and if it when you're connecting it, if it doesn't work, just flip it over, it'll work. And then like I said, coding through the browser is great, and then you're using C++ language for our specific case. Raspberry Pis are great because they allow you to use Python, which is more powerful. And then there's two functions. One is a setup function and one is a loop function. The setup function is only called once as soon as you power it on. The loop function is called every single, every fraction of a second. And so whatever code you have in is going to be called. Particle photons are great because they have access to particle functions, particle variables, and particle events that can be used to change values externally. And we'll look at that a little bit. So how do you set up a particle? You download the particle app, you can enter the Wi-Fi, and then you set up the device. You can use this code over here, and then you say particle token create. You can get that token as well for our code. What are these different components that you see over here? This is just an expanded view. This is a resistor. LEDs are extremely small, and if you pass 5 volts of current, they'll actually blow up, even though you don't get an electric shock unless it's 30 volts. So you're totally safe, but these are so tiny, so you need to use a resistor to reduce that voltage load. And this is the microcontroller. These are a bunch of wires. This is a breadboard. So how does the current flow, and how does this breadboard just do its magic? So you remember we said ground is negative, and so the electricity goes from the ground using this, so the breadboard, everything is horizontal and vertical. So current flows horizontally here and vertically here. So over here, it flows horizontally using this cable. It goes over here, negative all the way here to the resistor. Resistor takes it over here, goes up over here to the negative end of the LED, moves to the next line, then comes this way, comes that way, goes to D6, okay? In our case, it's actually at D1, just for the sake of the code. And then, there's different on and off states. So when it's on, it shows you like this. When it's off, it can show you like that. The good part about Particle, like I said, it's connected to the cloud, so you can access these functions, Particle functions, from the internet. And we're going to look at this as well. And you can just send a post call using a form, and it will make that API call for you. Okay. This is a particle variable. You can get the status, the current status of something. It'll send it back with whatever result value. And yeah, let's take a look at it. So as I said over here, oh, stop. Go here. I'm just going to change this to the photon page. Okay, so particle, this is the area where you put in your code, the C++. There's a setup function, like I said, and then you have the loop function over there. Okay, and then you can add different particle like code basically. So you see over here, this is particle function. So you can call this function externally, and once you call it, it passes in the value into this function that you basically call externally. So super powerful. And then what you do, you show what device you want to push your code to. So you can select this device. You just tap that. It will select that device. There's two devices that are live. I have a Raspberry Pi and a Photon. And this is, I believe, free to access. And then you need a personal access token that, like I said, you get from your terminal. So once you're here, once you have the setup, what you have to do, you just basically let me go to this code over here. Yeah. So this is the HTML code like I showed you over there. And to turn on or to basically toggle the color, you can just tap that, just say do it. And if you notice, oh wait, I think it was already on. Toggle this, go to, yeah, do you see the light change over there? Just through using our browser. Okay, so it's pretty nice, pretty neat. But like now the question is, what can we do with this? You can put that basically inside your code as well, and have a bunch of commands over here. When you click on a button, you can have it to where it changes that LED light on or off. So you use the access token, use the device ID, use the name of the particle function, and just basically get it called. And so we built this app, and now we have it on the mobile app. And so when I click on the mobile app, or you notice that the light immediately went on. When I hit off, the light goes off. You see that? And how instantaneous it is. These are not connected through Bluetooth. These are not connected through cable. It's connected to the cloud. And so notice how it's so responsive and so neat to use. Okay, that's awesome. You can actually control something physical. You can control something physical using your phone. And they can be in totally different parts of the world. What next? So, well, did you know you can actually connect this to other Internet of Things devices? For example, there's something called If This Then That. There's hundreds of thousands of devices in the world that have similar functionality. For example, you have Nest bulbs and things like that. You can say that if you tap a button on your particle device, you can send an SMS message, you can make a phone call, and you can do that using your particle photon as well. So you just search, create a new applet, set up particle photon, and just say, okay, when the variable is a certain value, you can change the light of your LED bulb. So over here in front of me, I have an LED bulb um, that's a hue bulb. And so when I change the value, I have it set up to where it'll change the color of that LED bulb as well. It's a little slow because I'm using the free version of If This Then That, but it definitely works. And we'll take a look at that as well. What have I actually used it for? Hold on, give me 1 second. So I have actually used it for one, like I used to live in a basement and it was always cold over there. And I didn't really control the air conditioning. The landlord did. Toronto, everything's super expensive. That's where I live. And so I needed to I used to tell the landlord that it was cold all the time, but she didn't really understand how cold it was. So I built this little device. I mean, if you see, there's one device and then there's my particle photon. This is the temperature humidity sensor. So I used If This Then That to send those values of the temperature over to a Google Sheet. And this is all free that you can do today. And, I built a graph and I was like, dude, it's like 20 Celsius over here. It's really, really cold. And I think it was going down to like 10 Celsius sometimes. And so, like my landlord immediately made changes. Like, okay, this guy has like data and he has a graph and everything set up. Yeah, so that was kind of neat. Now, let's say I want to use a Raspberry Pi instead. So Raspberry Pi is super cheap and inexpensive to get. Like I said, these are microprocessors, so they're an actual computer. So I have my Raspberry Pi set up over here. The resolution is a little off, but usually the resolution is a lot better. So you can connect it to your TV and have a smart TV. Um, and you can code it in Python, so not just C++. Um, there's all these amazing features, but once you buy this, you also need to buy an SD card. So don't forget the SD card because otherwise you can't really do anything. Once you have the SD card, you can download their Imager software on Mac or Windows, and just select the Raspberry Pi OS and just select that you want to write that OS onto your SD card. And then you hit write, it goes through the entire thing, and you essentially put that micro SD card into your Raspberry Pi. Yeah, and so these are just basically the steps, and then you can set up Particle using your Bash, and set up your free account. You set up Particle, and you can now use build.particle.io, that online IDE, in order to push code onto your Raspberry Pi, which is also super cool. And then you just need to update the device ID in your Xamarin code. So, going over here, all you need, like I said, all you need to do is you say build particle-agent space setup. Once you're connected to Wi-Fi, you run the bash script, and then you are able to do this. It'll ask you for your username and password. See, I'm already logged in. And then you are able to see that in your build.particle.io setup over here. So let's show under devices. So very simple. If you already have a Raspberry Pi, I highly recommend just do this. If you don't, I highly recommend buying a Raspberry Pi. So, there is an obvious difference between the microcontroller and the microprocessor. So why can you do stuff with the Raspberry Pi, not like a regular computer? That's because you have these pins over here, and they allow you to access certain items directly. So if you see, this is a pin out diagram of the Raspberry Pi, and I'm specifically cared about the 5 volts, the ground, and then these digital pins over here. So 11, 13, and 15, which is basically the 6th, 7th, and 8th pin from the left side. So these ones over here. And now, in order to actually use it to create a Raspberry Pi pump, what we can do is we need a power supply, that converts the 110 volt from the power, or the 220 volt, depending on where you are in the world. And it converts it. You can get this for like $5-10, I think, from China. Definitely get a certified one. There's the power in, which is from the alternating current, which is usually more dangerous to use because the 110. Remember, 30 volts is the limit before you can actually get an electric shock. And then it converts that into 12 volts. See, you can just use a thin wire coming from there. And then you use that to power up your pump. And then on the other side over there, you have your Raspberry Pi that's controlling a relay. So this is a relay, which is basically like a switch, but it can electronically be triggered, okay? And essentially, if you pass in 5 volts, it opens the switch. If you remove the 5 volts, it closes the switch. And that is what is used in order to turn on and turn off this pump. You don't need to power up the Raspberry Pi separately. You can just use this power supply in order to power it, but you have to step down the voltage from 12 volts to 5 volts because the Raspberry Pi runs on 5 volts. And then, you just have your app that actually dispenses the stuff. So all we need to do over here, we just need to change the device ID from what we had before to the new device ID. So I'm just going to change that. And let's hope to see if it works. So let's go there. Bam. We have all our electronics connected. This is our Raspberry Pi. And it's building the code. Ta-da! Let's see. It has it set up over here. And let's say on. Off. No. Okay, let's see. Let's debug what's up with this. Oh, I thought I heard something. So over here, what we're doing is we're just saying, okay, pay attention to this, and whenever I change that value, go ahead and make a change over there. So let's debug this. Let's try to make it work. So you go here, you change this value over here to this. Live demos are always a very, very big challenge. Let's see. But let's try to see if we can make it work. Particle. I'm going to go back to my code. Let's go over here. By the way, the code is all open source, so you can get that code whenever you want to for free. You can watch this video again, and you're not going to miss out on any of this stuff. Let's look at this. Let's say, so I have this, and I'm going to select the device to be the Raspberry Pi. I flash the code, and then I go back over here. I use the it just started by itself. Let's see. Yeah, so essentially it's set up to, seems like always be on for some reason, somehow. And are you able to see, like, this is the motor that's spitting out the Raspberry Pi. I mean, that's spitting out the sanitizer. So like that.
Hey, Samir, we're at time. I'm so sorry to have to interrupt your awesome demo.
I'm glad it worked, though.
But really, like you said, right, all the course is open source, available on GitHub. People can try it themselves. And I'm sure that you can also, post a video showing everything, how it's working. really cool demo, and really another way to show that .NET these days runs pretty much everywhere on devices, at the edge, in Azure, and also, on my TV, right? And on all kinds of different places. So really cool. All
Yeah,
right. So
thank you
I
so
want to
much.
thank
I
you.
really appreciate it. And, it was awesome to be here.